Okay. So let me first of all refresh your memory about what is a quadratic expression. Okay. So what is a quadratic expression? And it's any expression that can be written in the form ax squared plus bx plus, I guess I should put y equals ax squared plus bx plus c. I guess that's not an expression. Well, now we get rid of it. Just the ax squared plus bx plus c. If I put an equal sign in there, it's no longer an expression, it's an equation. So I'm just going to leave it without the equal sign, so that way we've got just an expression. Okay. There's one little exception, though, we have to kind of like take into account. All right, a cannot equal 0. Okay, a cannot equal 0. What would happen to our expression here if a was 0? What would we have? If a was 0 in this expression, what would happen to this thing? If a was equal to 0, so there's our a, right? If that a was equal to 0, what would happen to this thing? What would simplify? What would happen if a was 0 here? Well, we have a times x squared, right? So if a is 0, and we multiply that with x squared, what's that going to result in? 0. So that x squared term would completely go away. And it would leave us with just the bx plus c. The bx plus c. Is this quadratic? No, right? There's no square. There's no x squared, right? This is a line. If you were to graph this, it's a line, right? The b would be like the slope of the line. The c would be like the y-intercept. Okay? So it's important that we can, say anything that can be written in this form, but a can't be 0. A is not 0, it's no longer quadratic. So we need to make sure that's true. Okay. So yeah, that's a quadratic expression. All right? And so there's different ways we're going to be factoring this thing. Okay. So when it comes to factoring, okay, I'll just write this. Factoring can mean many things. Okay, so for example, you could be talking about greatest common factor, right? GCF. And we've got to write that out, greatest common factor. Okay, greatest common factor. Or we could also refer to what I'm going to call product sum. Okay, and you'll see what I mean by that. There's like grouping to. Okay, I'll put that in parentheses. We're going to do that later. Okay, and then there's others too. Okay, I'm focusing today on factoring with greatest common factor, factoring with product and sum. Okay, method. But the other strategies we'll see, we'll use those. Actually, we're going to use grouping a little bit today too, I guess. But the other kind of strategies, we'll kind of learn those as we need them, right? But today we're going to focus on greatest common factor, product sum, and then grouping as well. Okay, that's going to be kind of our goal here. Okay. So let's take a look at a quadratic here. So the challenge, some of the challenge here, right, is that you'll just be asked to factor, right? And then it's up to you to decide how I'm supposed to factor, right? What to use to factor, right? Some problems you'll want to use GCF, right? Because like that'll be something you can do. But not every problem, when you're asked to factor, not every problem will have a GCF that you can factor out. So you have to like determine that, right? And then also you have to determine, can I use product sum, right? That's part of the factoring too. Can I use that method, kind of thing? Whether or not you can or can't. Well, again, you have to figure that out. Okay, that's part of the challenge here. So, because some things don't factor. Okay. So anyway, let's take a look at an example here. So let's factor the following, we'll say. Okay. So I'll start with something that's hopefully not too terrible. Let's do like okay, 3x squared minus 12x. Oh, thank you, sir. And when it comes to factoring, okay, again, think about these different strategies here as different tools that we can kind of apply to each scenario, right? And I would always encourage you to look for a greatest common factor first. So, looking at these two terms here, is there a GCF? Is there something that we could factor or divide out of both of these terms? Is there something they both have in common? Okay, a 3, right? 3 divides evenly by 3, 12 divides evenly by 3. So let's go ahead and do that. So if I pull out a 3, right, and then I have some stuff left over in parentheses. If I divide the 3 out of this, what will be left over? X squared, right, x squared, yeah, that's right. Okay, very good. If I divide a 3 out of this, what will be left over? Negative 4, right, yeah, it's 4, right, but it's a minus, so we'll call it minus 4x there, okay? And there it is, okay? We factored the 3 out. How can you check your work to make sure you did it right? Well, imagine if you were to redistribute that 3, right? Imagine if you did the 3 times the x squared to 3 times minus 4, you'd go right back to this, right? So these are equal. Okay. Is there anything else in common to our leftovers here? Is there anything else we can divide out of these leftovers?
X.
Yeah, an x. Yeah, they both have an x, right? And Lindsay, you said x too, right? So yeah, divide on. Did I hear you say x?
Oh, yeah.
Yeah. Oh, no, yeah, you were right. That's right. Okay, divide an x out. Okay, so the 3 is out front already. We'll pull an x out with the 3, so it'll be 3x now, 3 times x. If I have x squared and I divide out an x, now what do we have? Just x, right? Okay. And if I have a minus 4x and I divide out an x, what do we have left? Just the minus 4, right? Yeah, the x is gone. Okay. Is there anything else in common between these two terms that we can pull out of the problem here? No. We're done. Okay, that's how we know we're done, right? We look here, there's nothing left to factor out, so we can stop. Okay, so this is the fully factored version of our original expression there. Okay?
You just left the answer, the 3 outside of it.
Mm-hmm.
Would that be right? Did you mark that right?
I would give you partial credit, yes. But you really want to make sure you pull everything out. Because when we do factoring, right, it's not called just the common factor, it's called the greatest common factor. So that means you want to pull out the most you possibly can, right? So yeah. And in fact, I would even say, Michael, that if you're gonna lean to one side, I would really focus on trying to make sure, just because of how greatest common factor works and stuff like that, you want to focus more on pulling out your variables than you do the coefficients. So like the first thing we pulled out was a 3, which is like just a coefficient, the number in front, right? But then the second thing we pulled out was an x, and that's actually more important that we pull the x out than the coefficient. Okay, so it's more important that you see the variables. So try and look at the variables first to see if there's anything in common. There won't always be, but sometimes there will. All right, let's do. Good question. That's a good question. Let's try one more here, and then we'll go on to something that uses product sum. Because I feel like GCF is one of the ones you guys, I feel like tend to be strongest with. So okay, let's do 4, and it doesn't have to be an x variable either, right? So let's do like 4t to the third minus 2t. Okay, I draw my t's with a little tail on them so that way they don't look like plus signs. Okay, they don't look like addition. Okay, so add a little tail so it doesn't look like addition. But you don't have to. You can do whatever you want. Just don't get mixed up. Okay. Yeah. Sure. Okay. So again, all we're told is to factor. We have to determine what skill to use here. Let's try GCF first. Is there something in common to both of these that we can pull out?
Yeah.
Yeah? What? Okay, a 2. Okay, so let's factor out a 2. So 4t cubed divided by a 2, what will I now have? Yeah, 2t cubed, right? Okay. And then if I pull out, if I divide out a 2 from this, what's going to be left behind? Yeah, just a t, right? Minus t, or you could say minus 1t if you wanted to, right? Because 2 divided by 2 is really a 1. So you could say, oh, you can put a 1 in there if you wanted to. We can also just leave it as t. Okay. Is there anything else we can factor out in common? Okay, yeah, they both have a t, right? So let's take a t out. So I'll have 2t and 2t. And then take a t out of this. Okay, taking a t out of this, what do I now have? 2t, yeah, squared, right? I had t cubed, which is t times t times t, right? 3 t's. If I pull one of those t's out, I only have 2 t's being multiplied, so it's t squared. And then if I factor the t out of this, what's t divided by t? Not t. 1, right? Something divided by itself. T divided by t, that's going to leave us with a 1. Okay? And so there we have our factored answer. Okay? That's as factors we can make right now. Now, my next question to you, do you need to, well, no, I won't ask you guys this. I mean, just to say, you don't need to take 2 steps to do this. So some of you may get to the point where you feel comfortable, where you can look at this and see, oh, I can take a 2 and a t out. You can do that at the same time. So in other words, you can go from this step if you want to, and you can jump right to this step. You don't have to do it, step by step if you don't want to. If you find yourself having difficulties, though, do it this way. Go step by step. Look for numbers that you can factor out first, then maybe look for variables you can factor out, okay? And go from there, because that can help too. Sometimes you just, you got to take it step at a time. But sometimes we'll be able to look at it and just pull everything out at once like that, from here to here. So do what you need to do there. Okay, questions on any of that? All right, so that's GCF alone, okay? Now let me show you this product sum. That's what we're going to be really focused on today, because this is going to be kind of like the most used skill that we have for this quadratics, or when it comes to factoring, stuff like that. Okay, so let me show you here. So same directions. Okay, now we're going to use product sum too, though. I'm going to put this in parentheses so that way you can differentiate between these. Okay. So again, remember our directions are to factor, right? We're still factoring here. If we wanted to use GCF here, could we? Is there something in common to all 3 terms here? Do they all have an x? Do they all have an x?
Yeah.
These do.
These 2 do, but not
But this does not. So no, they do not all have an x, right? For a greatest common factor, that word common doesn't mean like plain or ordinary, like you might think, like common, people or whatever kind of thing. Common means like in common with someone, shared, right? So like that version of the word common. So greatest common, it needs to be shared by all 3. So this does not have an x. Okay, so no. How about any numbers? Are there any numbers that divide 3, 20, and 7 evenly? The only number we could do is 1, right? That's it, right? So, and that's not going to help us because that doesn't really reduce our numbers. So we can't use GCF here, right? So GCF doesn't work. Now let's try this product sum thing. So when we go to factor these quadratics, okay, in this form, okay, I guess this wasn't a quadratic, so shame on me. I should have done that one. Oh well. Anyway, when we go to factor a quadratic, okay, in this kind of standard form, that's what this form here is called, standard form. In fact, maybe I'll write that out here. Standard form, okay, is what that's called. Okay. When we go to factor in standard form, we're going to use this thing called product sum. Okay, and here's kind of basically how it works. Okay. multiply A times C. And you might hear me refer to this as the AC method instead, okay, because A times C, okay? So in this case, in this particular case, okay, what is our A? Which one of these numbers is the A coefficient? The 3, right? It's the number in front of the x squared term there. So it's going to be 3. So A, in the example here, A is equal to 3. And what's our C term in here? -7. That's right. Good. Okay, again, that's where the C is, right? C is the constant. A is that number in front of the x squared. Okay? And so then A times C is going to be -21. Okay, -21. And then the next thing we want to do, and here's where that warm-up comes into play, we're going to find two numbers, bless you, that multiply to AC and add to B. Bless you. Bless you again. Okay? So for our example, we're looking for two numbers that multiply to -21 and add to make, and what's our B term in this problem? 20, yeah. Okay, so here's where the warm-up came into play, right? So step 1, right, we multiplied our A coefficient times our C coefficient. 3 times -7. 3 -7 makes -21. Then our step 2 here is we want to find two numbers that multiply to AC, right, that -21, and add to make B, which is the 20. So here's where the work comes in, right? We have to think of two numbers that multiply to -21, but add to make 20. So, any ideas?
20
So 20,
that would be
yeah, 20 -1. And again, how about, so again, we want to multiply to -21. So what about like 21 and -1, for example? Right? So again, two numbers that multiply to -21 and add to make 20. Okay? So let's try like 21 and -1. Does this multiply to give us -21? Right? Yes. Does this add to make 20?
No.
21 plus -1?
Yeah.
It does add to make 20. All right, it does. So we're going to take these numbers, all right, split up B using the numbers you found, okay? And then we're going to factor by grouping. Okay. I'm going to do this work over here. And again, it's a lot to write out. I think once you kind of see it happen a couple times, it'll make more sense. Okay, it won't be too crazy. Okay. So let me just keep going here. Yeah. Sure. So the middle term 20x, right, we're going to break it up using these two numbers that we figured out, right? So plus 21x minus 1x minus 7, just like that. Okay. if I were to combine these like terms, right, 21 minus 1, they would combine right back to that original. But I'm going to break this up because now I can group these first two together, and there's a GCF I can take out of this first group. What can I take out of this first group? A 3 and a... well, there'll be a 7 left behind, but I could both of these numbers divide evenly by 3. What else can I divide out from both of these terms here? They also both have what? An x, right? So I'm going to take out a 3 and an x at the same time. Okay? So taking 3x out of here, the 3's gone, so now I have a 1. X squared, take out an x. Is just x, right? Okay. 21 dividing out of 3 is now 7, and then if I take the x out, there's no more x left over, so it's just x plus 7 like that. Okay. So far so good. Questions on this step right here? Does that make sense to everybody?
I remember this strategy from last year.
Yeah. Yep.
Can I go to the
You
bathroom?
might. Sure.
It was algebra 1.5.
I gotcha. That helps too. Okay, now for the second group. What can we divide out from this second group? What's in common here? What can we divide out of both of these? They both don't have an x, so you can't do x.
Divide by a negative.
Huh? Yeah, -1, exactly right. Let's factor out a -1. So that leaves just an x behind here. And then what's -7 divided by -1?
That's positive.
Yeah, positive 7. You'll know you're on the right track if you have the same leftovers. Okay, so when we factor the GCF out of this group, our leftover was x plus 7. And we factor the GCF out of this group, and our leftover was x plus 7 as well. So we know we're on the right track because we have the same leftovers. Okay, so we're going to factor one more time here. Both of these things have an x plus 7. Okay, excuse me. And then left behind is a 3x and a -1. And there it is, fully factored. Okay, we're taking out the x plus 7 out front. Okay, like that. Question.
What do you do with the -1 in the middle?
So that -1 right here. So when I take the x plus 7 out, Michael, right from this group, I'm left with 3x. When I take an x plus 7 out of this group, I'm left behind with the -1. So the 3x and the -1 go back together right there. Make sense? Okay. And we'll do a few more here. Don't sweat it if like you're like, okay, you feel like you kind of got it, but you need some more practice. We'll do a few more, okay? All right, let's try another one here. We'll do at least 2 more here together, and then I'll have you guys try one, maybe 1 or 2. All right. So let's try another one here. Okay. Again, we'll keep our same directions, factor. Okay. 5x squared minus 17x, excuse me, plus 6. Okay, so again, let's pretend that you just came across this problem, in the wild somewhere, and you need to solve this. All right, you need to factor it. All right, the first thing you should look for is GCF. Is there a greatest common factor to all 3 terms? Is there something we can divide out of all 3 terms here? No, right? These have x's, but this one doesn't. This one divides by 5 and by 1, but none of these divide by 5. So, yeah, there's no GCF here. So we'll just go to our AC method then. Okay? So, A times C. What is our A in this problem?
5.
5. What is our C in this problem?
6.
Yeah, 6. Okay. And so we get 30. Okay? So we want 2 numbers that multiply to 30, but then they also need to add to make that -17 there. Okay? So let's see here. What are 2 numbers that multiply to make 30?
15 and 2.
Okay, 15 and 2. Okay? They multiply to 30. Do they add to make -17?
One of them has to be negative.
So does 15 and 2 add to make -17? The answer is no, they make +17.
So they both have to be negative.
So let's make them both negative. Negative 15 times negative 2, does that multiply to make positive 30?
Yes, it does.
Negative times a negative? It does, right? Negative 15 plus negative 2, does that add to make negative 17? Yes, it does. So these are our two numbers, okay? So we're going to take 5x squared. We'll subtract the 15x minus 2x plus 6. So again, we're going to take that middle term there, the negative 17, and break it up using those two numbers we found. Okay, negative 15, negative 2. All right. Group the first two. Group the second two. From this first group, what can we factor out? Okay, they both have an x. We can take an x out of that first group. What else can we take out of that first group? They can also divide by 5, right? So we take out a 5 and an x. And then if I take a 5x out of here, I'll have an x left behind. I take a 5x out of here, I will have what left behind here? What's negative 15 divided by 5? 3, yeah. And x is out too, so it's just x minus 3. What can I divide out of this group right here? A what? Yeah, 2. And let's do a negative 2. Let's make a negative 2, and I'll show you here. So let's take out a negative 2. So negative 2x, take out negative 2 is just x. 6 divided by negative 2 is negative 3. There you go. Okay? And hey, look at that. We have the same leftovers again. Okay? So we're on the right track, right? X minus 3, we're the same. So we'll take these two out. Okay, so factor out the x minus 3, and then what's left behind if we take out the x minus 3s? 5x minus 2. And there it is, factored. Question mark?
Does it matter the order you put them in at the end here?
No, you have, so my question to you, right, is 2 times 3 the same thing as 3 times 2? Right, so order of multiplication, long story short, doesn't matter, right? So if you have x minus 3 here and the 5x minus 2 here, that's fine. Okay? So yeah, doesn't matter. Same thing here. Some people might have written minus 2x. Did you write minus 2x and then minus 15x? Is that what you did? And that's fine. Yeah, it just factors slightly different, but the answer ends up being the same. Okay? Yeah. So, all right, let's do one more together, and then I'll have you guys try one on your own. Actually, this one will be hopefully easier. We'll see, but it just depends. Okay. Maybe I should do that. Is there a GCF for this one? Is there a GCF here we can factor out? No, right? There's not all the terms have an x. This one only has a, what number is in front of this x squared? 1, right? And then we can't divide anything else except for 1. So we just said that the number in front there is 1. So a times c is going to be 1 times, what's our c here in this problem? 20. So we get 20. Okay. We need two numbers that multiply to 20, but add to make negative 9. So blank times blank equals 20, but then these same blanks have to add to make negative 9. Okay. So, two numbers that multiply to positive 20, but add to make negative 9. Mike? Negative 5, negative 4, you got it, that's right. Yeah. Negative 5, negative 4, right? Negative 5 times negative 4, positive 20. Negative 5 plus negative 4, negative 9, right? So those are your two numbers right there. Okay, good job. Sadly, no. So the way, so like let's say you come across this problem. So you're okay with getting to the point where you know that you need to multiply to 20 and add to negative 9, like you feel confident about that? Okay. So what I would encourage you to do is to try to think about pairs of numbers that multiply to 20. Okay? Because there's fewer of those pairs than there are pairs that add to make negative 9. And then at that point, Paige, it's kind of like, I don't want to say guessing and checking because you're not really guessing the numbers, but I mean you're choosing and checking. And then if they don't work, you just keep working and keep going and stuff like that. So for example, you would probably be able to, Paige, no problem, come up with like 5 and 4. and you see 5 times 4 is 20, 5 plus 4 is a positive 9, she might say, ooh, 5 plus 4 was a positive 9, I need negative 9, maybe I should make some of those things negative. So you'll be able to develop some strategies the more you do it too, but sometimes, yeah, it's going to be tricky. Yeah. So anyway, there is no easier way, unfortunately. Okay, so we'll break up that minus 9x. Okay, group the first 2, group the second 2. What can we take out of that first group? What's in common to both of these? The x. And so I'll have an x minus 5 left over. Right? X squared, take out an x is x. 5x, take out an x is 5. What about from this group? What can we divide out of this group?
Can divide by 4.
A negative 4. I'm going to take out a negative 4. And so then negative 4x divided by negative 4 is just x. Positive 20 divided by negative 4.
Negative 5.
Negative 5. Okay. Same leftovers. So that means we'll have an x minus 5. And then the leftovers will be x minus 4. And there it is factored. Okay. Ready to try one on your own? All right, here's one for y'all to try. Sorry, I should say factor here again, right? I want to make sure I give you directions. So try factor, okay? If you feel good about that one, I'm going to go ahead and give you another one here too. Yeah, go ahead. You're welcome. Should be, yeah. Mm-hmm. Yep, it should be. It should all be out of it will all be out of the book. And Michael, I gave you a review, right? The test, like the yellow packet or whatever kind of thing. Do you still have that?
Yeah.
Okay, if you still have that, that'll also be helpful for your review. So.
All right. Still with mine?
Okay.
Yes.
Yes, and you're welcome.
Thank you.
Do you think we can go to finish it with the amount of time we have left right now?
I'm not sure.
Well, you want to give it a try at least? I put them here. Yeah, there you go. That's the one.
That's one actually.
Okay. All right, is anyone still working? Okay. So let's take a look here at number 1. Let's go to Paige. Were you able to come up with something here?
She's in the bathroom.
Oh, she's in the bathroom. Shoot. Never mind. Jeez, I should have realized that. No Bobby either. All right. How about Lindsay? Were you able to factor this?
Yeah.
Okay. So did you do the 5 times the 3 and stuff like that?
Yeah.
Okay. So let's see here. 5 times 3 is 15. Okay. And so we need 2 numbers that multiply to 15, but add to make what there, Lindsay? 8. That's right. And what 2 numbers multiply to 15, but add to make 8? 5 and 3. You got it. So that middle term here, I'm going to go down here. So we have 5x squared plus 5x plus 3x plus 3, just like that. Did you split it up this way with a 5x first and then 3x?
Yeah.
Okay, cool. So group the first 2. From that first group there, Lindsay, what can we take out?
I had 5x.
Yes. Okay. Yeah, x plus 1. When we take the 5x out of both these terms, 5 divided by 5 leaves a 1. X squared dividing out an x leaves an x. 5 divided by 5 is a 1. X taking out an x, there's no x left. Okay, and then how about from this second group here, Lindsay, what can we take out?
So then 3.
Yeah, just a 3, exactly right. And we'll be left with an x plus 1 again. And that's good. Bless you, we got our leftovers. So x plus 1 times 5x plus 3. There's our factored answer. Okay? Okay. Great job, Lindsay. Well done. All right, let's go to Matthew. Oh, hello.
Dr. Sperry wanted me to see if you can make a list.
Yes. All right. Thank you. Sorry. Thank you for reminding me. No, because I would have forgotten. So thank you very much. Okay. Awesome. All right. Let's take a look at this one here real quick. Okay. So A times C. Let's go to Matthew. What's our A here in this one, Matthew?
1.
1. What's our C?
12.
Negative 12. Yeah. Okay, and so we're looking for 2 numbers then that multiply to make negative 12, and 2 numbers that add to make what in this case? 3. Okay. Were you able to come up with 2 numbers that did that, Matthew?
No, I
Did you get to this one? Okay. Was anyone able to figure out 2 numbers that did that? 2 numbers that multiply to 12 and add to make 3. You have an idea, Lindsay?
No.
Yeah.
I haven't guessed that.
Okay. So yeah, there's only a couple combinations, right? We could do negative 1 and positive 12, or positive 1 and negative 12. We could do 2 and negative 6, or negative 2 and 6. We could do 3 and negative 4, or negative 3 and positive 4. Right? Those are the only combinations that multiply to make negative 12. Do any of those add to make a positive 3? Do any of these add to make positive 3? Yeah, no. This thing, it doesn't factor. Okay? So, not every quadratic expression is going to factor. And that's something we need to keep an eye out for. Okay? Would I be so cruel to you to ask you to factor something that doesn't factor? I'll try not to do that, okay? I really want to make sure that if I ask you to factor something that does in fact factor, because that's really frustrating, especially there's like a lot of things that you want to check, you have to check and stuff like that. So, but do understand that is a possibility. We'll have to, when it comes to solving and stuff like that, we'll have to come up with a different way to be able to solve this. Okay, so there is that. Okay. Questions on any of that? So this is something we'll be doing again and again, factoring, I mean, throughout like the following week in this unit, okay? So it's going to be important that you have this skill down, okay? So we'll have more practice though too if you still feel a little rusty. Speaking of practice, I gave you guys this hilarious pizzazz worksheet here. You don't need to do the whole thing. In fact, I'm just going to ask you numbers 2 through 12, and you can skip number 10. Okay, so 2 through 12, skip number 10. Now look, I know that these pizzazz worksheets have answer keys that you can look up on the internet. Okay, and I obviously can't stop you from doing that, but if you don't practice this, right, then you aren't going to learn it, and when it comes to a test, you won't be able to look up the answer key on the internet, right? So please put in the time and actually practice these problems here from the worksheet, okay? Don't just blow it off, Googled it, pizzazz, and, just take the answers there, all right? Please actually do try to factor these. You're only going to be, hurting yourself by not practicing. Feel free to look this up if you want to check your answers, right? That's fine, right? If you need some help, maybe it'll be helpful. Okay, of course, we'll go over this in class on Tuesday. Okay. Don't come into school Monday. No one will be here. Okay. So that's your assignment then. You can work on that right now. I can come around and help you guys, but those are the problems I'd like you to do, 2 through 12. Right. Yeah, when I say getting rid of, right, we are doing division. Anytime you factor, you're really dividing. So 5x dividing out of 5x leaves a 1 behind. Okay. Yep. And same thing with the 3 that you had there, too. Yep. Excellent question. Good question. Just a heads up, folks, tissues are not recyclable, okay? So please don't put tissues in the recycling bin. Okay, we have a whole list of things that are recyclable here. Tissues, unfortunately, are not one. Same thing with food or your food bags, like any chip bags and stuff like that, not recyclable. Okay, so please don't put them in the blue bin. Okay, so only these things. When in doubt, throw it out. Oh, any choice? Oh, they're your thing? Okay, all right, well, thanks. Sorry, guys. You can say you don't have to worry about it this week because obviously normally I don't make you make up warm-ups. You can just put that you're absent or whatever in the future. I'll make sure that you go. There's one. That's one. There we go. Okay. All right. Very good. Okay. Very good. I will get you your credits then. Thank you.
Oh wait, is this homework?
This will be homework if you don't finish it in class. You're right. Yep. Mm-hmm. Yes, this is homework. I know I'm giving you homework on a 3-day weekend. Ooh, Mr. Widmeyer.
What are we doing? Hold on. What?